So there are two formulas that you can use to help calculate the area of a triangle. One of them is called Heron's formula, which is literally a couple thousand years old, goes back to an ancient Greek mathematician. Heron's formula relies on this parameter called S, which is half the distance around the outside of your triangle, or so-called the semi-perimeter. So if you calculate S, then you can plug things into this formula and get the area of a triangle. So let's check that out here with the area for triangle K. And let's see here. We've got A, B, and C. Those are going to be sides of 5, 4, and 8. Add that up and divide by 2. So 17/2. And now what we're going to do is we're going to fill that into Heron's formula. Personally, what I like to do is I like to use my graphing calculator and use the store key as part of that. So I'm going to take that 17/2 and store that in X. So watch carefully, the store key is to the left of the number 1 on the lower left-hand corner of the calculator. So store, and then a convenient place to put it is X, because we can get to X pretty quickly. Now the reason I do that is because it makes it easy to enter in this formula. The formula would look like this. It's going to be the square root. I'm just going to call that S. Square root of S times S minus 5 times S minus 4 times S minus 8, where this is your value for S. Easy enough. Now instead of the S, we're going to be using an X. We'll start out with the square root, X, and then parentheses X minus 5. Another set of parentheses, X minus 4. And finally, X minus 8. Close parenthesis and enter. Bam, that's it. That's the area. This works well for triangles if you have all 3 sides. If you have 2 sides and an included angle, then there's a different formula that we're going to use. But before I move on to that, are we okay with this? You could probably do the same or similar thing with Desmos, but let's see, question from somebody out there?
Yeah, that's interesting. I got like an error when I typed that in.
Really?
Yeah. Oh well. Actually, you know what? Let me.
Did
I don't
you?
think my store saved, so that could be it.
Oh, okay.
Sorry.
Anyone else on this one? Okay. Let's try another one. The one down below. Now, I'm sure you've seen a formula, area equals 1/2 base times height for the area of a triangle. And that works well when you've got a nice right triangle or something like that where you know the altitude. But if you don't have that, you can still find the area of the triangle. The formula is going to be area is 1/2 A times B times the sine of the angle in between those. So in our case, 1/2 A, which in this example was 4, right here, and then times 5 times the sine of 95. So effectively, that's going to give me 10 times the sine of 95. Make sure your calculator is in degree mode before you calculate that. So I need to change this. Change over to degrees. And the 1/2 times 4 times 5 is just 10. So I'm just going to type in 10 sine of 95. Bam. So about 9.962 approximately. That's pretty much it. So what you're looking for is an area. If you have all three sides, use Heron's formula. If you don't, then figure out two sides and an included angle. So an angle between those two sides, and that'll do it.
What angle did what side did 95 correspond to?
It was the angle between the two known sides. So let me see if I can't make this a
Oh, it
little.
was gamma.
Yeah, I didn't really
basically.
label it in terms of an alpha, beta, and gamma, but
Okay.
let's see. Right here. So
Okay.
it was the angle between the two known sides is what it is.
All
Okay.
right.
Yeah, and if you're sticking with the notation I've used earlier in this chapter, then yeah, there'd be gamma. Gamma's opposite side C. So
Okay, thank you.
you're welcome. Thank you. One other little note here, and it's something that comes up somewhat frequently. I don't know, somewhat frequently is probably overstating it. It does come up from time to time, and it's just kind of convenient to know. It's not something I'm going to quiz you on, but just know that there's a nice formula for the area of an equilateral triangle. Of course, equilateral triangle means they have all three sides the same. All three of the interior angles then have to be 60, and the area of that is just given by this nice formula that really relates to the sides. And that's actually something you can prove with perhaps the law of cosines, but actually not necessarily the law of cosines. I don't know. I've proved it myself before, but it's just nice to know it's there. You can look it up when you need to, which is what I did. But it's a handy little formula from time to time. So just know that it's out there.